Good morning. This is Tim Stewart. I am president at Visual Decisions, and we are here today to talk about improving Kaizen with Industry 4.0. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements such as 30% increases in OEE, 50% scrap reductions, and much more. So with that, let's go ahead and get into the presentation. What we're going to talk about today is improving Kaizen. So first, we'll do just a couple minutes on Kaizen itself as well as Industry 4.0. So what is Kaizen? At a high level, Kaizen is both a philosophy and an activity. As a philosophy, it's really the belief in continuous improvement. As opposed to going for big step changes in performance, Kaizen or continuous improvement is the idea that you're just going to make incremental and very rapid and continuous changes that help you improve that performance on a day-to-day basis. As an activity, it's a structured event intended to improve a process or a product. One thing I want to point out is that while manufacturing has embraced technology and automation, a lot of operational excellence teams have not. Still using whiteboards, still using very manual, paper-based processes and so forth. And there's an opportunity to utilize technology and embrace that to really drive a lot of improvements in a much more rapid fashion. What is Industry 4.0? Industry 4.0 encompasses a lot of different technologies. The graphic over on the right side with very minuscule print comes from the World Economic Forum and talks about a lot of the different new and emerging technologies, as well as some of the things that are fairly mainstream at this point. And some of those technologies that I'm going to emphasize today as I go through this are artificial intelligence, big data, machine learning, augmented reality, industrial Internet of Things, and so forth. So what are the steps in a typical Kaizen process, and how can Industry 4.0 solutions improve that? Well, if we look at a typical Kaizen process, there's a lot of different ways that you can structure this. And this is just one typical example that I happen to have a graphic for. But in this process, we break this down into 6 steps. The first is to identify the problems. Where should we do the Kaizen in the first place? Then analyzing the current processes, creating solutions, testing those out, measuring and analyzing the results, and then standardizing that solution, both in that particular process, as well as where can we generalize that and standardize that across different processes. So let's take these one step at a time. So in the first step, what we're looking to do is to identify problems in our process. And my background, I did lean consulting for a significant period of time. And I would work with a customer, and they would bring me in specifically to help them run a Kaizen event. And I would ask them, how did you decide to do a Kaizen here? And usually it was because that was where a machine went down last week, and they wanted to make sure that didn't happen again. It was someone's complaining about that, or we just want to improve things overall, and this seems to be where we're having a lot of problems. And so it's usually a very informal process to decide where we're going to run any given improvement event. And I mean, that's fine. The whole spirit of this is that we want to run a lot of these different events in different areas and continually improve the process. But If you're looking at making the biggest impact that you can in the fastest possible way, you want to be able to take a more data-based approach to this. And so if you can have data that identifies for you where your wastes are, that's going to significantly help you target these more effectively. And so utilizing data, you can identify where you have different types of waste in the process, whether that's downtime on machines, whether it's overproduction, whether it's any of the standard wastes that you have from a lean manufacturing perspective, and really tie that into what is the dollar value associated with that waste to the organization. And if you can do that, then you can start to very rapidly prioritize what is our improvement funnel. What are the things that we should do first? And as you're looking at that, you certainly want to also prioritize those in different ways that we'll talk about later in the presentation. So in terms of identifying where you have big problems, one current state is this is a very common SQDCM board: safety, quality, delivery, cost, manpower. Other companies add I for inventory, E for environmental, etc. But a very typical process of identifying what are the key metrics within the organization and manually tracking those and figuring out where those gaps are. And this is for a lot of continuous improvement, operational excellence organizations, kind of the state of the art in terms of how they go about identifying where those gaps really reside. From a process perspective, this does work. It may not be rapid, but it highlights very carefully, or very clearly, I should say, where you're green, where you're red, where you're good, where you need attention. It also, keeps people involved in that process, because people have to go up there and manually make those notes on the board and so forth. So that's all good. Some of the disadvantages to this, it is a very manual process. And so there's a lot of waste that's involved with this in terms of people having to go over there, manually do this. There's a lot of rework in terms of people manually putting these things on here, and then somebody taking those sheets, entering those into Excel, then other people taking those Excel spreadsheets and combining those to do some form of analysis and so forth. And so it's not a particularly efficient process. The other aspect of it is that because it's very manual, it typically doesn't go very far beyond this. So while you have tremendous flexibility in terms of what you want to mark up here, you don't have a lot of flexibility in terms of going deeper. The metrics, there's only so much room on that paper form. And unless you start really expanding how big that board is, there's only so much information you can put up there. And so what I've done with a number of different organizations is to really digitize this and collect that information automatically from the source. And one view of that I had for a customer looks like this, where we have a big board, and this is also available on everybody's computer. It's available on your phone. It's available on an iPad or whatever, and you can instantly see for the current period, for the last period, et cetera, in real time, basically, where do I stand on all of these different metrics? And so from each of the different sources for the information, we're looking at safety incidents, we're looking at customer complaints, first pass yield, cost of scrap, et cetera. And we're able to show, are we green, are we red? What was the target? What was the actual? And then also, what was the actual explanation for that? What was the reason for any given miss? As well as now looking at what what is the corrective action that we're putting in place, who's responsible for that, et cetera. And then, there's drill down behind this as well, so that if I want to, click on one of those cells, I can drill into the details behind that information. And so, being able to really target, what are the different issues that we have, and furthermore, what is a consistent issue? Not just because we missed it last week, we want to do something now, but where are the places that we're missing consistently? And we can start to trend those. We can start to chart those out, and actually look at for this plant, this line, this particular machine. This is where we consistently have issues that need improvement. And so, significant capabilities that we can add here that aren't in the other process. And because, most of this is generated automatically, there's significant less waste in that process as well. So you might ask where we get that data from, and, how do we identify those problems in the first place? And for most organizations, you actually have a ton of data that's available. Whether you're utilizing it or not, you have PLCs that are generating information all the time. You have Excel spreadsheets out there. You have information that gets buried into your ERP system. You have maintenance management systems. You have quality systems. You have SPC charting. You have laboratory systems. Non-conformance systems. Lots and lots of information that's getting collected. What most companies don't have is a good way to look across all of that information, to be able to collect it, put it in one place, and actually look at that as one whole, and be able to see the context of that data across those different systems. And so what we've done with our customers is utilizing either information hubs on the shop floor, like an IIoT system, or an analytics system such as a Tableau or Power BI or something along those lines, to be able to pull information from those different sources. Either way, either approach, you get a much more comprehensive view, and something that you can go into and look for one source of the truth. So, as I said earlier, once we have all of that information gathered from all of those different processes, from those different systems and so forth, and we can create kind of what that portfolio looks like. Now we want to start prioritizing those and deciding, how do we want to go about determining which Kaizen events we want to run next. And so, over on the left, what I typically look at is both the value of the project as well as the time to value. So the things that we want to run first are the ones that are going to give us a tremendous amount of payback, but also generate that payback very quickly. And so if it's something that we've got to order capital equipment for, and it's going to take us 6 months to get the equipment and then implement it and test it and everything else, those are things that are good to put in there, but might be deprioritized because they're going to take longer, even if they have a big payback associated with them. So, the things that we want to, ideally run first are the ones that are, quick to do, but also provide a big return. In addition to that, we want to look at the interdependency, of these different things. Are certain, changes that we can make foundational that will enable other rapid changes, afterwards? And then, how much confidence do we have in the cultural readiness of our people? Are they trained properly? Do we have all the other, conditions that need to be met in order to make this successful? And so, that's kind of the next factor that we look at when prioritizing these things. And then just what are the overall priorities of the organization, for something that might improve quality versus something that might improve throughput? Which of those is currently more important to the organization? So once we've decided on which program we want to run, then the next thing that we have to do is look at that process in more detail and analyze that process to figure out, what are the driving factors behind this. And so there are many common methods to analyze root causes for problems. And depending on the nature of the problem, different methods are appropriate. And depending on how much time you have to go about this, different methods are appropriate as well. And so some of the common methods are listed here in terms of just asking why 5 times, mapping this out in terms of creating just visuals for this, doing fault tree analysis, running through a practical problem solving process, creating a fishbone, all the way to more Six Sigma methods, looking at analysis of variance or design of experiments, to look at what are the driving factors behind either the variation in the process or what are the contributing factors to that underlying performance and so forth. And so there's a lot of different ways of analyzing this, but every single one of those is reliant upon data. Even something as simple as just looking at who, when, where, why, how process. You still want data, and you still want to be able to contextualize that data in terms of, well, when we see downtime, are we typically running a particular product, or do we have certain operators that see that downtime a lot more than other operators, or do we see that at certain times of the week or certain times of day, or are there environmental factors that drive that, heat, humidity in the ambient conditions within the factory, et cetera. The more data that you have, the better job you're going to be able to do in driving down into those factors. So in terms of analyzing those current processes, it's very common to spend the first several weeks of a Kaizen project, just collecting the required data. And I don't know how many times I've stood out at a machine or a line with a clipboard and a stopwatch, and just collected data on how many times we saw different causes of failure, and what was the impact of each one of those, how long was each downtime event, and so forth. The problem with that, other than being very wasteful in terms of resources and everything else, is that you collect biased data. Just like when you're driving down the highway and there's a policeman, people tend to slow down. People fundamentally behave differently when they know they're being watched. It's called the Hawthorne effect. And when somebody is standing at the line with a clipboard and a stopwatch, people behave differently. They run the process differently than they normally do. And so the data that you capture, first of all, may not capture infrequent events. So if you're looking at something that happens sporadically, it's very difficult to get a big enough sample to really understand the underlying causes. But it's also something where even if it's a frequent occurrence, you may collect data that doesn't represent the true process. And so if you implement systems that collect data 24/7, you have a much better understanding of the way that that process actually functions. So an example of this is at a bread manufacturer. We implemented a system that collected data 24/7, really looking at the data that they already had and just pulling that into a database, and then pulling that into this was Click, for just putting together some analytics on top of the existing data set. And with this process, we were able to pretty rapidly identify different areas of the plants that had issues, different categories within those areas, different causes, and then what product was being manufactured, who was running the process, et cetera. And so as we drill into this interface and just click on the biggest bar to drill down, what we find is that equipment loss was our biggest issue, and within equipment loss it was the oven. And then within the oven, what we were seeing is that on a daily basis we didn't have much downtime, and then we had these big spikes of downtime, and we were able to identify that what was happening was that the oven shelves were flipping due to broken pins. And so the pins that were holding the conveyor would fatigue as they went into the oven, out of the oven, into the oven, out of the oven, etc. And over time, they just fatigued and broke. And so we were able to implement a preventive maintenance routine that addressed that during off days, and we eliminated entirely the biggest source of downtime for the entire facility. And we did that because we had the data available to identify what was going on and home in on that very quickly. That's one type of pattern that you can identify with the data. Another very common thing that you'll see is that you don't see this type of a profile in the data. You see just random times lost on a daily basis. And instead of putting a preventive maintenance fix in place, what you typically need to do for those is more of a poka-yoke or error proofing type of fix that needs to be put in place. And so the data will tell you not only where those problems are, but a lot about the nature of the problem and the nature of the fix that needs to be put in place to address that. And that takes us to our next step, which is creating solutions. And so, as we look at, how we create solutions to these different problems, understanding the nature of, the root causes is obviously critical, but, being able to brainstorm and, come up with a variety of different potential solutions is, the next critical step in this. And if we look at another example is something very simple. I had a customer that made shampoo, and in their packaging area, they had an overhead conveyor that fed bottles into the filler. And as I was looking at the data for that, what I saw there was that second type of profile where there were just a lot of downtime issues at the filler. And because they were so short, they typically didn't get a reason code associated with why it was down. They were only tagging downtime reasons for things that were over 5 minutes in duration. And so I just saw a lot of performance losses on that filler. And so I went to the line and was looking for those short reasons. And what I saw was that that overhead conveyor kept jamming, and the bottle feed would stop into the filler. The operator was managing the entire packaging line, and so it would take them a little bit to see what was going on, that the filler had stopped. Once they saw that, they would walk back there. They would, see what had happened. They would actually grab a broomstick and they would poke at that conveyor until it cleared. And then the bottle feed would resume, and they would, start production again. Now, that worked, but, it actually added up over time in terms of how much downtime was accumulating. That was actually their biggest single source of loss on that line. And so what we were able to do is, once we identified that was a problem, I asked, how often does this happen? And they were like, well, that's just the way that the line works. And so there's this tendency to just kind of accept those common sources of downtime as the way that the process functions. And so as you're looking to create solutions, you have to, and identify the, problems in the first place. You have to be very aware of that mindset that just accepts, the daily way that things happen, and really identify, what are those root causes, and then what can be done about that, as opposed to just poking it with a broomstick every single time it happens. And, in this case, we were able to just grab a ladder. We, adjusted the rails in that conveyor. We put some silicone tape on there, and, we eliminated that source of downtime. And so, a lot of those things, as you look at the different ways that you can create solutions to these problems, instead of just poking with a broomstick each time, you have to think through what can be done to, address this in a more permanent fashion. Another benefit of Industry 4.0 here is that it really expands the solution set of what can be done. And here I'll kind of turn to an FMEA process, or failure mode and effect analysis. When you look at the probability of failure, the severity, and then the probability of detection, there's things that can be done for each one of those in terms of mitigating those. Certainly from the probability of failure, we've talked about some of the things that we can do to identify and eliminate root causes for different failure modes. In terms of mitigating the severity, being able to decrease the mean time to repair for some of these things is also very important. So if it's something that we can't prevent from happening, but we can notify people immediately, put work procedures in place and so forth, give assistance to operators, so that instead of having to wait for somebody from maintenance, they can do this themselves. Those are things that can be done with Industry 4.0 solutions to mitigate the amount of time that we lose to some of these different failure modes. But then also, sometimes it's just being able to increase the probability of detection for hidden failures. So being able to utilize machine learning to look at what's happening on the machine, being able to predict that in advance, being able to classify different problems and let people know what is happening, so that they can address those issues before it becomes a bigger problem, are things that can really improve the overall performance. And those are things that we can put in place with these Industry 4.0 solutions. When we look at increasing that solution space, utilizing things like the industrial Internet of Things, being able to collect that data, not only just the output data, or the whether it's running or not running, or how many pieces are being produced, but going down into the PLCs and being able to get what is the heat, what is the power draw, noise, vibration, all kinds of different information that are going to be leading indicators of these different issues, are things that having those IoT solutions, having that capability in place, can help us either prevent the failures from occurring in the first place, identifying them more rapidly, or mitigating them once they do occur. So once we have identified a potential solution to this, how do we go about testing it? And so one way is that we can kind of start small and scale it quickly. Being able to if it's something you're just taping the guide rails, or putting a PM program in place, to be able to see what that PM interval should be and so forth, for making sure those oven shelves don't flip. Those are things where being able to put that solution in place is very rapid. But putting, for instance, the silicone tape on that guardrail was something that we did as a short-term solution. We saw whether that worked or not to prevent the failures. And then, over the longer term, what was done on that line was they, made a more permanent adjustment that didn't rely on silicone tape to keep those guardrails aligned. and I made that investment at that time. But first we started small, just with the tape, to see if it would work and eliminate that problem. One of the other things that you can do with some of the Industry 4.0 solutions here is to use simulation. And so if you're going to have to do something like capital investment or something along those lines, you can simulate the change in that process if you have those digital capabilities in advance of making that capital investment, so that you can be sure that once you put that in place, it's going to have the intended effect. And if you think about something like the goal, where you have different constraints within the organization, and if you break this constraint, is it just going to improve the process marginally, because then you have another problem that's going to become the new constraint? And if that's the case, you have to think about making a change to both of those in order to get the real value. Another thing that I'll talk about here, and then I'll emphasize again later on, is with the solutions that you put in place, you don't want to create monuments. From a lean perspective, a monument is something that is unmovable, and that can be a physical thing within the plant. So if you've got a pole that is load bearing, that's a monument within your facility. You have to plan around that. With these technical solutions that you put in place, you don't want to create technology monuments that are going to be something that you have to plan around in the future. So I advise using as flexible solutions as you possibly can, and that way, if you need to bend those in a different way in the future, you can do so. All right, measuring and analyzing the results. This one is pretty obvious. I won't spend a lot of time on this one. Obviously, if you have these solutions, you're collecting the data 24/7. You've put a solution in place. You've tested it out. You've scaled it. Now you can look at the results before and after and be able to identify, are we seeing the value that we were expecting, or do we need to, tweak that solution in some way in order to get that value? In terms of standardizing the solution, the big key here is standard work. So, as you are creating the solution that you're putting in place, you obviously want to create the standard work around this so that you can really embed this within the day-to-day process and really the culture of the organization. And the standard work can be for that process itself, but you can also create standard work that utilizes this airproofing solution or PM or whatever it is across different cells, across different departments, plants, etc. If this is a new best practice, make sure that that gets standardized throughout the organization. The other thing I'll add here is that when you are using systems as part of that solution, it does make it easier to standardize or systematize that solution, because you're essentially putting that new workflow into that system. You are putting something in place that helps to standardize the way that people approach that. And so there can be significant benefits to that, but again, what you have to watch out for is putting a monument in place. So as you put that into a system, make sure that that system can be modified easily in the future. One caution here from a technology perspective is that the technology itself isn't enough very often. Just putting an IoT solution, for example, out there isn't going to solve the problem. I use this example all the time of a Fitbit. I've been wearing a Fitbit for over 8 years now, and I've gained 20 pounds during that time. I would love to blame the Fitbit for that, but I can't. The Fitbit works great. It does exactly what it should. It has sensors, it collects the data, pushes it to the cloud, analyzes that, gives me all the pretty charts and graphs. But because I haven't changed my behaviors, I haven't, seen the benefits that I was expecting. And so it's not just, putting that technology solution in place. It is modifying that standard work. What are the behaviors that you want, getting those, embraced within the organization and adopted, and, people acting on that on a daily basis. So some closing thoughts. Data is absolutely critical to identifying those improvement opportunities. Caution to avoid technology monuments. And so as you're looking at different technology solutions, be careful of things that are inflexible. Very much what I typically recommend are more platform type of approaches where you can build that custom workflow, but then you can also go back in and change that at a later time. If you buy solutions that only work one way, well, they're only going to work one way. If you are, building that custom solution on top of, a platform, there's a strong overlap here with agile concepts of building a minimal viable product and then making incremental solution improvements on top of that. And so that very much fits in with the whole Kaizen or continuous improvement philosophy. And then because of that desired flexibility, our recommendation is to utilize those solution platforms such as IIoT or AR combined with those agile methods to continually improve the process and supporting technology together. So with that, I thank you all very much. If you have any questions, please reach out to me at tim@visualdecisions.com, or my phone number is right there as well. I should be reaching out to each of you in the future to discuss this topic, and if you have any questions within your own environments. So thank you very much for your time, and I look forward to continuing the conversation in the future.